From life-saving pharmaceutical products to priceless minerals, marine resources clearly possess enormous value. But it is the fishes that inhabit the world ocean that are probably the most accessible and consistently useful resource in the marine environment. Not only have they provided a source of food for humans since the earliest of times, but they play a critical role in the global food web as well.
Fish are obviously one of the prime ways that we get protein out of the ocean. I think about a third of all the protein in the world is now coming out of the sea. And fish are just sort of an upper place on the food web. You have your plants of the sea that are actually creating biomass, and things eat the plants and things eat those animals, and sort of transfers mass material up the food web. And at some point along the chain, you get to something that we want to eat.
People have found ways to get fish from the ocean for thousands of years. But recent advances in fishing technology have brought about major changes.
There was a time when we went out with sailboats and chased fish around, and it was much more of a challenge for the fishermen to be successful. Of course, the fishing stocks, the fish supply was a lot higher then as well, so they were successful using fairly archaic, primitive equipment. Now we've evolved to the point where we're using very large horsepower, fast boats with very sophisticated fishing technologies, the trawls and the dredges and the baits. We have really advanced our ability to fish, so our efficiency at fishing has greatly increased over the past 20 years.
Unfortunately, this increase in efficiency comes at a price.
The particular project that I'm working on is looking at trawling fisheries around the peninsula region and the subantarctic island arcs. When a trawler goes out for fish, it not only captures fish, but they're dragging over the seafloor, so they capture a lot of the invertebrates that live on the seafloor as well. And I'm looking at that bycatch and trying to quantify how the trawling is impacting the habitat of the fishes. A lot of the sponges that they bring up can be hundreds to maybe even 1,000 years old. And so once a trawler goes by, it takes a very long time for the community to recover and come back to normal. And you might ask why we would care about a sponge in the Antarctic. You can't really eat it. It's, not directly impacting you. But the sponges provide habitat for the fishes, and once you remove all the sponges in an area, the fish have no place to lay their eggs. They have nowhere to hide from seal predators. So it does have an impact on the fishery itself.
The impact of new fishing technology goes beyond environmental costs. The sheer number of fish being removed from the marine habitat can lead to a serious problem known as overfishing.
To know an area is overfished is fairly obvious. The fishermen know immediately because it's basically return per unit effort. I mean, probably the biggest and most obvious clue is they just stopped seeing the numbers of fishes in the nets that they were getting when the population was stronger.
And if you have records that are kept by the government or the fishermen, whoever, you can see this gradual decline. And when it gets to a crisis point, for example, at a level of about 20%, where the spawning biomass is reduced by that amount, you're looking at species that can't recover, at least very fast. And you've got to stop fishing altogether. So you look at catch rates, you look at the size frequency, that means the range of sizes. As the fish get smaller and smaller and smaller, pretty soon you're at the point where they're not reproducing. You're catching them before they reproduce, and that's going to cause a collapse, a total collapse.
As concerns about overfishing increase, the need for effective fishery management becomes critical.
One of the tricks of fisheries management is to balance the interest of fishermen, which is making a living, with the interest of the fishery, which is for those organisms to survive, and from our standpoint, for the ecosystem in which they live to not be degraded by that fishing activity. And they aren't the same interest. And that blending of the business side of fishing with the ecological side of fishing is, I think, one of the places where we've then had trouble historically in managing fisheries.
Fishery management focuses primarily on maintaining a sustainable harvest of resources. There are a number of factors that complicate that process.
If you were a forestry manager, you could go out and you could measure your trees and you could count your trees and you could look at the density and the growth rate, and it's all very simple because they're all sitting there right in front of you. Fisheries managers have a much more complex problem.
In practical sense, we can't count the fish very easily. We have very poor methods of actually going into the ocean and counting who's there the way you might count how many elephants are on a plane. And so we have to use indirect techniques. And really one of the main techniques, the fish we see are the ones the fishermen take out of the ocean. Declining size is one of the clues that there are fewer fish. The big ones live longer. There's a longer period that they can be caught. If they're over-harvesting, the larger ones will start to disappear. So you can have a situation where the average size of a swordfish in the Atlantic a century ago might have been 200 or 300 pounds. Today you're lucky if it's 100 pounds. That says that the big ones are gone, the long-lived ones are gone, and you've started taking enough fish out of a long-lived system that the population size structure has really changed.
But while indirect evidence provides some useful insights, there's a great deal about fisheries that remains a mystery.
And so the fisheries managers have had to resort to numerical modeling or using mathematics to try to predict what's going to happen with our fisheries populations, with the number of fish in the sea, if you will. And what they need to do is they need to understand how these fish function on a normal basis, and then they have to predict what's going to happen if you take away a certain number of those fish. Is the population going to be able to sustain itself, or are you going to see a slow or rapid decrease in the population or increase in the population?
Many oceanographers contend that the models used in fishery management are inherently flawed.
Fishery management requires as good a data set as possible. That data set normally assumes that a fished stock will reach an equilibrium condition that gives it a carrying capacity or population level that's slightly lower or somewhat lower than it would be if it wasn't fished. And all the models that I know of are based on equilibrium assumptions. That is, the fish stock will stay in equilibrium. Now, if a fish is going out of existence or its catch per unit effort data are going down very fast, that means it's not in equilibrium anymore. And that's the biggest fault of the fishery models we have.
In large part to counter problems caused by overfishing, marine sanctuaries have been established at various points along U.S. coastlines.
Marine sanctuaries are not unlike the concept of a national park or a terrestrial reserve or a wilderness area. They're areas that have been designated such that human activities are reduced. The amount of reduction can vary from absolutely no touching anything by anybody to maybe simply reduce fishing for a particular species.
One of the major challenges in setting up a sanctuary is determining how much space a particular species needs.
I think the general consensus is we need more sanctuaries, marine protected areas, and the larger the better. The other part of it is that it also seems to be a way to help sustain and improve the marine environment that's different from the traditional regulatory scene, which has been, in the United States, as far as I'm concerned, largely a huge failure.
In recent years, the relationship between fishermen and regulatory agencies has grown increasingly strained.
In the old days, and I would say the last 100, 200 years, the fishermen would fish certain resources, and when they found that they had declined, they would most likely switch or fish a different resource and then go back and forth. As the human population has expanded rapidly, the fishing pressure has increased amazingly, thus causing fishery management agencies to be more numerous and to wield more power. So the relationship between the fishing industry and the management agencies has become less comfortable because the management agencies have had to impose more strict regulations and rules.
The best application is at the local level, where the community recognizes the need to control, and then you get community-based management regimens or programs that are put into place. Those seem to work best because then the local people take charge. I think really you need to get down to the level of the fishermen and make it somehow in their interest to control what they're doing. Give them incentives to follow regulations. You have to make it in their interest to preserve the fish that they're targeting.
The trouble is they don't know the amount of fish that they're fishing that are available any more than the fishery management agencies do. So ultimately, I think the Canadian example might be used, and that is to use the fishing industry with the fishing management agencies to gather the data that are then used by committee in general to manage those resources.